AI moves fast. Here's what matters. This is AI Daily for January 13th, 2026. Why did Google partner with PayPal and Shopify to sell digital coupons that expire in 17 seconds flat, directly to AI agents? Imagine a future where your AI buys things for you, but it may soon expire. Today, don't fall into the anti-AI hype. B7708, statement by Federal Reserve Chair Jerome F. Powell, plus our deep dive into Google announces new protocol for AI agent commerce. Let's go.
Here's your AI Daily News Roundup for January 12, 2026. First up, Simon Willison's reminding us all to not fall for the anti-AI hype. And honestly, it's a message we need to hear. There's a lot of negativity surrounding AI in our community, and while some of that criticism is valid, outright dismissing AI's usefulness for software developers is a dangerous game. Think about it. AI is automating tedious tasks, assisting with code generation, and even helping debug. Ignoring these tools means falling behind. It's becoming increasingly clear that integrating AI skills into your workflow is becoming a must-have career skill. Staying informed and adapting is crucial, not just hoping it all goes away. Moving on, we've got a new release from llama.cpp. Now, this might seem like just another version bump, but pay close attention. These frequent updates signal ongoing development and refinement of local LLM inference. Why is this important for you? Well, llama.cpp allows you to run powerful language models directly on your own hardware. No cloud connection needed. This is huge for privacy-sensitive applications, offline development, and even just experimenting with AI models without relying on expensive cloud APIs. Plus, the broad platform support, macOS, Linux, Windows, means you can integrate it into virtually any development environment. Make sure you check out the release notes to see the specific fixes and optimizations that might benefit your projects. In other news, Jerome Powell, chair of the Federal Reserve, gave a statement. And yes, even economic news matters to us in the AI world. Why? Because the Fed's policies directly impact interest rates, which affect investment in technology and AI startups. A strong economy often leads to more funding for AI research and development, while a downturn can lead to budget cuts and layoffs. Understanding the macro environment is key to predicting the future of AI investment and job opportunities. While the video and article might seem dry at first glance, take some time to understand the potential implications for our industry. Also making waves today, Simon Willison's followed up on his earlier experiment porting code with LLMs. He's addressing some of the ethical and legal questions raised by using AI to automatically translate code bases. This is huge. As we increasingly rely on AI for code generation and porting, we need to have serious conversations about copyright, licensing, and the potential for introducing biases or vulnerabilities. Willison's tackling these questions head on, and his insights are essential reading for anyone using or planning to use AI for code-related tasks. Ignoring these ethical considerations could land you in legal trouble or damage your reputation. Next up, a bit of controversy from Anthropic. Apparently, they're banning the use of their Claude Code model to develop a competitor. While this might seem like a standard competitive move, it raises some interesting questions about the future of AI model development. Are AI companies going to start restricting the use of their models to prevent the creation of competing products? If so, this could stifle innovation and limit access to cutting-edge AI technology. It's a reminder that even in the open source world, there can be restrictions and limitations on how you can use AI models. Finally, a handy tool for all you Apple users, an iCloud Photos downloader. While this might seem like a niche utility, the popularity of this tool highlights a common pain point: data ownership and portability. Many developers are building tools to help users extract their data from proprietary platforms and services. This is important because it gives users more control over their own information and reduces their dependence on specific vendors. As AI increasingly relies on personal data, ensuring users have the ability to access and control their data becomes even more critical. That's the news for today. Now let's dive into our deep dive topic: how to responsibly manage and audit the data our AI agents use. Okay, so I'm looking at this TechCrunch story about Google's new protocol for AI agent commerce. And my first reaction is, isn't this just AdWords for LLMs? It feels like we're just reinventing a fancier, more conversational ad placement.
I had that exact same thought. It's so easy to be cynical and see it as just another sponsored tag in an AI summary. But the more I dig into the protocol part of the announcement, the more I think it's architecturally way more interesting than that. It's less about ads and more about creating a standardized, machine-readable contract for transactions.
A contract? What do you mean? Like a legal contract?
No, a technical one. Think of it like a step beyond what schema.org does for SEO. Schema.org lets you mark up your page so Google understands this is a product, this is its price, these are its reviews. It's descriptive. This new thing, let's call it the Agent Commerce Protocol, or ACP for short, is prescriptive. It tells an AI agent not just what a thing is, but what you can do with it and exactly how to do it.
Okay, so you're saying it's not just metadata, it's an instruction manual for an API that my e-commerce site doesn't even have yet.
Exactly. Imagine you're a merchant. Right now, to get your products into Google, you submit a Merchant Center feed, a big XML or CSV file. It's static. It gets updated maybe once a day. With ACP, you'd host a manifest file, maybe at a well-known endpoint like .wellknown/agent-commerce.json on your domain.
A well-known endpoint. Okay, that's a classic pattern. So Google's crawlers just look for that file?
Right. And inside that JSON file, you don't just list products, you define capabilities. A capability might be purchase t-shirt, and that capability object would contain a JSON schema defining the required inputs like size, color, and idempotency key, and critically, the API endpoint to call to execute the purchase, like api.mystore.com/v1/agent purchase.
So you're essentially publishing a lightweight, standardized API definition for your store. This is what you meant by a contract. The manifest is the contract.
Precisely. And it's not just for purchasing. It could be for reserve a table, book a test drive, or apply 10% coupon, each with its own schema and endpoint. This is the part that gets me excited from a developer's perspective. It's a move away from scraping and unpredictable web automation and towards structured, predictable interactions.
Okay, but here's what I don't get. If I have to build an API endpoint anyway, why do I need Google's protocol? Why not just build a really good REST API and tell people about it? This feels like it's adding a middleman.
That's the key question. The value is in discovery and trust. You can build the world's best API, but how does Google's shopping agent, acting on behalf of a random user, find it? And even if it finds it, how does it trust it? How does it know how to authenticate?
So the protocol standardizes off too?
It has to. The spec they've hinted at suggests a JWT-based flow. When a user tells the Google agent, hey, buy me that shirt from Alex's store, the agent makes a call to your agent purchase endpoint. In the authorization header, it passes a JSON web token signed by Google. Your backend's job is to validate that JWT signature against Google's public keys.
Ah, okay. So my API endpoint middleware would have a step that's basically verify Google JWT token, and inside that token's payload, I'd get the user's identity, or at least a pseudonymized token representing them, and maybe the specific offer they agreed to.
Exactly. The token payload would contain the claims, like user ID, offer ID, price at agreement, so you can verify that the agent isn't trying to buy something at a price that you didn't offer. This prevents a whole class of race conditions where a price changes between the user seeing it in the AI search and the agent executing the purchase.
That sounds great on paper, but what about the really messy stuff like inventory? My agent sees an offer for the last pair of sneakers in stock. It gets the user's go ahead, but in those 30 seconds, someone else bought it through the regular website. What happens when your fulfillment endpoint gets that JWT and the thing is gone?
That's a failure mode the protocol has to account for. The response from your endpoint isn't just a 200 OK. The ACP spec would define a set of standardized error codes, so you'd return a 409 conflict with a specific error body, like error inventory exhausted, message the requested item is no longer in stock.
And the Google agent is then smart enough to parse that specific error and relay it to the user in a natural way, like, oh, sorry, it looks like that just sold out. Would you like me to find a similar one?
Right. It makes the agent's interaction with your backend predictable. It's not just guessing based on a generic HTTP status code. It knows the difference between inventory exhausted and payment token invalid. This is a huge deal for anyone who's ever tried to build a robust scraper or automation tool. The ambiguity is the killer.
So, for a developer at, say, a mid-sized e-commerce company that's not on Shopify, the first step is to convince their boss to build these new, very specific API endpoints. What does that dev's life look like for the first month?
First, they're probably defining the schema for that agent-commerce.json file. They're deciding which one or two products to start with as a pilot. Then they're building the new endpoint. Let's say they're running a Node.js service on Kubernetes. They'd add a new route in their Express app, like app.post/v1/agent-purchase.
And the middleware for that route would be crucial. First, the JWT validation. Second, probably some serious input validation against the schema you published. You can't trust the agent to send perfect data.
Absolutely. You'd use a library like Zod or AJV to validate the incoming body request against the schema you defined in your manifest. Then comes the core business logic, creating the order in your database, calling your inventory service, and crucially, handling the payment.
Right. The announcement mentioned PayPal and Shopify. How does that piece fit in? Is Google's agent handling raw credit card numbers? Please say no.
No, thank God. That would be a non-starter. The way it works is that the user has their payment methods linked to their Google account, which is already integrated with partners like PayPal. When the agent gets the go-ahead, it first orchestrates a payment token generation with PayPal behind the scenes. That payment token, a single-use, secure string, is what gets passed to your endpoint in the request body.
So in my Node.js service, I'm not calling the Stripe API. I'm calling the PayPal execute payment with token API.
Exactly. Your back-end's responsibility shifts from handling sensitive payment details to just passing along a pre-authorized token to the payment processor. For the Shopify integration, it's even simpler. Shopify's platform would just expose this capability natively. As a Shopify merchant, you'd flip a switch in your admin panel that says Enable Google Agent Commerce, and Shopify generates the manifest and exposes the secure endpoint for you. Their engineers do all the heavy lifting.
Okay, so for the 80% of merchants on platforms, this is a toggle. But for the 20% with custom backends, this is a significant engineering project. You're building a new, public-facing, mission-critical transaction API. You'd need monitoring, alerting, everything. You'd probably want to deploy this new endpoint with a canary release strategy, using something like Istio or Linkdir to slowly bleed traffic to it.
Oh, for sure. You'd watch the dashboards in Datadog or Grafana like a hawk. You'd want to track the success rate, latency, and especially the error codes. Are you seeing a spike in inventory exhausted? Maybe your inventory sync job is too slow. Are you seeing invalid JWT errors? Maybe Google rotated their signing keys and your service didn't pick up the new ones.
Going back to what you said about the manifest, this feels like it could get really complex. What if I have a product with dozens of variants or dynamic pricing? How do you represent that in a static JSON file?
That's a great point. I think for complex cases, the manifest might not contain the literal offers. Instead, it could define a capability for discovering offers. So the manifest might say, to get offers for product SKU 123, call this other endpoint. api.mystore.com/v1/agent-offers/SKU123.
So it's a two-step process. The agent first discovers the capability to query for offers, calls that endpoint to get a specific real-time quote-unquote offer object, and then uses that object to call the fulfillment endpoint.
I think that's the only way it could work for complex catalogs. The offer object it gets back would have a short-lived TTL and maybe a signature, so you can prove it was your system that generated it. It's a way to bridge the gap between a static definition of capability and the dynamic reality of e-commerce.
Huh. I hadn't thought of it that way. It's almost like a self-documenting, discoverable API for commerce. You're not just writing open API specs for other developers, you're publishing a machine-readable spec for autonomous agents.
And that's the paradigm shift. If you're using a framework like LangChain or Llama Index to build your own agent, this is a massive unlock. Today, to get your agent to buy something, you have to write custom, brittle web scrapers and browser automation scripts for every single site. It's a nightmare to maintain.
Right. The selectors are always breaking.
Always. But in this new world, your agent's first step would be to check for an agent-commerce.json file. If it exists, it can parse the manifest and know with certainty how to interact with that merchant's systems. You could build a LangChain tool, a Google Commerce Protocol tool, that knows how to handle the whole discovery, offer fetch, and JWT authenticated fulfillment flow. It abstracts away the complexity for the agent developer.
So, if I'm a senior engineer hearing about this, and I work at an e-commerce company with a custom-built stack, what should I be doing tomorrow?
I think the first thing is to start a design doc. Don't write any code, just start mapping out what this would look like in your architecture. Identify the services that hold product data, inventory, and order management logic. Figure out where this new agent gateway service would live.
That makes sense. And you'd have to think about security and rate limiting from day one. This endpoint is basically a direct line into your revenue system. You can't just stick it on the public internet without protection. You'd need something like an API gateway in front of it to handle traffic shaping and DDoS mitigation.
Absolutely. And you'd want to put it behind feature flags. Maybe use Launch Darkly to roll it out to only internal test agents first, then to a small percentage of real agent traffic. The operational side of this is just as important as the initial implementation. You need a rollback plan. If your Terraform apply goes sideways, how do you instantly disable the endpoint?
You could even build a simple CLI tool for your own team, something like ACP CLI fulfill-SKU 456-size-M that simulates a call from Google's agent, so your QA team and your CI/CD pipeline can test the endpoint without needing a full-blown AI agent.
That's a fantastic idea. A little simulator. It would craft a fake JWT with the right claims and hit your staging environment. That would be essential for testing all the failure paths we talked about, out of stock, invalid payment, and so on.
You know, the more we talk about the implementation details, the less it feels like an ad product, and the more it feels like plumbing. It's foundational infrastructure for a web where agents are first-class citizens.
That's it. That's the aha moment for me. We're talking about the protocols that will underpin the next layer of the web. For years, we've had HTTP for documents and REST APIs for developers. This feels like the beginning of a third pillar, a protocol for autonomous agents to transact with the world.
It's a big step, and probably a messy one for the first few years. There will be competing protocols, versioning nightmares, and massive security blunders.
Oh, it'll be a total mess, but it's the right direction. It's moving from unstructured chaos to structured interaction. For any developer testing systems that touch the real world, this is a signal that it's time to start thinking about your agent-facing API. It's not a matter of if, but when.
That's AI Daily for today. If you found this valuable, take a second to subscribe wherever you get your podcasts. And if you're on YouTube, hit that like button. It really helps us reach more people in the AI community. For deeper dives and weekly roundups, sign up for our newsletter at aidaily.sh. Share this with a colleague who needs to keep up. See you tomorrow.